Hello everyone. Today we're going to be going over slope y-intercept form of a line. So we'll start out with a little bit of a brain warm-up. We have a line with a slope of -2/5 and a y-intercept of 3. So feel free to pause the video at this point and try this out. We need to draw the line on the grid. So to start, I think I'm going to do the y-intercept of 3, so that means the line has to pass through there. And -2/5, so the slope is -2/5, and our slope is given by rise over run. So to get the next point from the y-intercept given, so 0, 3, we go down 2 and right 5. 1, 2, 3, 4, 5. There. We would further go down 2 and right 5, but we can see it's not on the grid anymore. So to get the point previous to this one, we would go 1, 2, 3, 4, 5 left and 2 up. So you can see 2 down, 5 right, 2 down, 5 right. So now we can connect these 2 points. So I know that's not right on the line, but I'm trying to get it parallel, and I'll just try to reposition it. There we go. So there's a line. State the equation of the line. So last class we figured out that we have the form y equals mx plus b. We put m in for the slope, which is that number, so I put that in place of the m, so y equals -2/5 x, and I put 3 in for b. So that's the equation. Next we need to find the value of y when x is 15. So I start with this equation, and I put 15 in for x to figure out what the value of y is. So -2/5, I put a 15 in everywhere I see an x, plus 3, and now it's just regular order of operations, brackets, exponents, multiplications, and so on. Okay, so -2 times 15 over 5. Obviously you can do that in a calculator if you like. What you can also do is just multiply it in the fraction form. So -2 times 15 is -30, and -30 divided by 5 would be -6. So -6 plus 3, and the result of -6 plus 3 is -3. Okay, so we're going to verify that with a graphing calculator. So there it is. That's a little bit wacky. Come back. There we go. Okay, so we're going to graph y equals -2/5. So I'm going to put the coefficient here in brackets. So remember to use that negative. -2 divided by 5. X plus 3. So graph it, and that looks like roughly what we have here. Let's maybe just confirm a few points. So I have 0, 3 for sure, and I have 5, 1 for sure as well. So let's confirm that we have those 2 points. So the value when x is 0, y should be 3, and it is, so y is 3, that's great. So check one more point. So when when x is 5, y should be 1, so let's check that. 5, y is 1. Okay, good. And if you wanted to, you could check x equals -5 as well, so maybe why not? Calculate value when x is -5, and that looks to match up with what we have here, -5, 5. So we're good. Okay, done. Alright, moving on. A line is drawn on the grid to the right. State the equation of the line using function notation. So remember, we need f of x equals blah blah blah. So instead of y equals blah blah blah, we need that version. Okay. So a couple things we can use. We have the y-intercept. It's at 0, 4. And we can figure out the slope too, so it looks like it crosses through, right? We're looking for the spots where it crosses through sort of the grid intersection points. So it looks like we got one there, looks like we got one there. So if we go, for example, from this point to that point, the rise is 1, the run is 3. So slope equals rise over run. We go up 1, right 3. So positive 1/3 is the slope. And that's all we need. So f of x equals mx plus b. M is 1/3 and b is 4. 1/3 x plus 4. Use the equation next to find the value of the function when x is 30. So f when x is 30. So notice I just replaced the x with 30 because x is now 30 in this particular case. 1/3 times 30 plus 4. And now it's just order of operations. 30 divided by 3, or if you like, 1/3 times 30 over 1 is going to be equal to 10. We add 4, that's 14. So the value of the function when x is 30, the function is 14. So f of x equals 14 when x is 30. Okay, moving on. Line is defined by the equation y equals 5 minus 2x. State the slope and y-intercept of this line. So notice, like, at this point we're accustomed to seeing y equals mx plus b, but because addition is commutative, as long as you keep the signs, I guess, in front attached to the number, we could write this as b plus mx just as well. So comparing these then, this is b, so that's b, and m, you need to include the sign as well. M is -2. So the slope is -2, and the y-intercept is 5. Okay, moving on, question number 3. A line is defined by this equation. State the slope and the y-intercept. So let's try, see what you think of this. The slope is 3, and the y-intercept is -8. Do you see any issues with that? Take a moment. So problem with that is I am expecting y equals mx plus b. So I can't make a direct comparison with this as it is in its current state because I have this pesky 2 kind of there. So in order for me to make a direct comparison and say that this number here is the slope and this is the intercept, I got to get rid of this 2 first. So that would be wrong just to say 3 is the slope and -8 is the y-intercept. What we need to do first is get this y on its own. So I guess in order for us to do that, we'll do that in a different color pen. If I divide both sides of this equation by 2, so that whole thing divided by 2 and that whole thing divided by 2, I would go 2y over 2 equals 3x over 2 minus 8 over 2. So everything gets divided by 2. We maintain the balance. So on the left, 2 divided by 2 is just 1, so we're left with y, and 3 over 2, I guess that just stays as 3 over 2, and -8 over 2 reduces to -4. So now we can make a direct comparison because it's in the form y equals mx plus b, and now we can say that the slope is 3/2 and the y-intercept is -4. Okay, next question. Draw the graph of 0.75x minus 1. So 0.75x, you can use that, or as an equivalent fraction, you may know what that is. It's a fairly common, right? Think about maybe quarters. If you had 75 cents in quarters, knowing $1 is 4 quarters worth, how many quarters is 75 cents? So 3 quarters. If you type 3 divided by 4 into your calculator, for example, you can confirm pretty quickly that that's equivalent to 0.75. So you may find it helpful to work with 3 quarters in this case rather than 0.75. And -1 gives us the y-intercept, so the y-intercept happens there, and 3 quarters, positive 3 quarters, rise 3, run 4, again rise 3, run, okay, it's off grid. So working the other direction, we can go down 3 and left 4 and connect the dots. So there's that. Okay. Just try to make that parallel. We'll fix it now. So that looks good enough. So that's the line. Verify using a graphing calculator. Okay, let's do that. So wake up. Come on. Maybe not. Yep, okay, there we go. Okay, so 0.75 x minus 1. Graph that. So, I mean, that looks roughly like what I have drawn here, but it would be good to check. So I know that that has to cross through 0, -1. So let's see. Calculate the value when x is 0. Y should be -1. Okay, it is. That's great. Let's find another point as well. This should cross through 4, 2. So when x is 4, y is 2. So x is 4. Okay, good. 4, 2. Great. So did that. Confirmed. Confirmed. Okay, moving on. Number 5. State the equation of the line that has a y-intercept of 1 and is parallel to this line. So if it is going to be parallel to this line, the slope of my equation, as stated up here, with a y-intercept of 1, should have a slope of equal to -2/3. So I require the slope for my line to also be -2/3, but I need a y-intercept of 1. I don't want it to be -2. So slight change, -2/3 x, that'll give me something with the same slope, so parallel to this line. And if I want a y-intercept of 1, b equals 1. So y equals m times x plus b. B is 1. That's my line. Okay, and if it's perpendicular to this line, that means I require the slope to be the negative reciprocal of -2/3, so that will be +3/2. So I will have y equals mx plus b, so m needs to be 3/2, +3/2 x, and b, as stated, needs to be 1. So that'll be my line. Okay, I'll get you to try this one on your own. So very similar to this one. You've got a parallel and a perpendicular one, and the y-intercept is needing to be -7. Okay, moving on, question number 7 I think we'll do. The equation of the line is defined by y equals mx minus 6. If it passes through the point 2, 4, determine the value of m. So we don't know what the value of m is yet. And if it passes through 2, 4, we have xy here. So that's great. I have an x and I have a y. So when x is 2, y is 4. So I can plug that in to my equation here in order to figure out what m should be. So instead of y, I'm going to put a 4 in its place. And instead of an x, I'm going to put a 2 in its place. And m will adjust its value to link up with this point. So 4 equals 2m minus 6, and now I just solve for m. So I can add 6 to both sides. That gets me 10 equals 2m, and then I got to divide 2 by both sides, so 10 divided by 2 is 5, 2 divided by 2 is 1, so m is 5. And you can confirm that, I guess, in a graphing calculator, might as well. So let's see. So I'm going to type y1 equals 5m, or 5x minus 6. So let's see, 5x minus 6. Let's graph that. Okay, come on, there we go. And we want to see that it passes through 2, 4. So let's try. Value when x is 2, y should be 4, and it is. Good. So, confirmed. Okay, try another. So the equation of a line is negative 3 halves plus b. So again, we have an x and a y given. We can produce from this an equation to solve for b. So I put a 7 in place for y, negative 3 halves. I put a negative 4 in place for x, and I just need to figure out what b should be. So this will be 7. Negative 3 times negative 4 is positive 12 up top, and positive 12 divided by 2 is 6 plus b, so b needs to be 1. I subtract 6 from both sides of that, and then we're good. Okay, and I mean, you can confirm that as well, so graph it, put this in your equation for y1, so y1 equals negative 3 halves. I'd probably put that in brackets, x plus 1, and then just see that the value when x is negative 4, y gives 7. Alright, moving on. The cost of a banquet is $200 for the hall rental plus $15 per guest. Complete the following table of values and use them to sketch the graph. So $200 to rent the hall. If I have 0 guests, it'll be 200. So, and then 20 guests, I'll have 20 times 15. That'll be for the guest amount plus the hall rental. This is 300 there, plus 200 gives us 500. Okay, and then on down the line, this will be 8, this will be 1100, 1400, 1700, and 3200. Okay, so let's graph. Looks like we've already got our axes nicely labeled here. Number of guests is along the bottom here. Number of guests. This will be the cost in dollars. So 0 guests, $200. Put a point there. 20 guests, $500. 40 guests is 800, so about there. 60 is at 1100, so there. 80 is, we're at 1400, so about there. Did I? Oh, I botched the 60. Let's try that again. 60 and what was it? 1100. Okay, there we go. 100 guests were at 1700, about there, and 200, 3200 is all the way up there. And I guess we can just connect these points. Why not? I guess officially the number of guests is discrete. But if we're like zoomed out for all purposes, I guess it looks like they're practically connected. So each one of these people, it'll be, it's fine. Okay, write an equation that relates the total cost of the banquet to the number of guests. So we have C equals 15N plus 200. That works. Okay, is it in the form of y equals mx plus b? Yes. I just have y being a c instead, and n becomes an x. Otherwise, all the same. Okay, the rate of change is $15 per guest, right? That's this one. It's the slope. Slope is like the rate of change, and it's the cost per guest. Okay, next, state the equation for the following graph using function notation and use appropriate variables. So you can pick any 2 points and figure out what the rise and the run is. So the run here going from here to here is 4, and the rise, it's a drop from 1,000 to 8,000, so that's minus 200, 2,000, sorry. Slope is equal to rise over run, negative 2,000 divided by 4, which is negative 500. Okay, and okay, so we got the slope, we need the y-intercept. The y-intercept is 1,000, so b is equal to, 10,000. And we need to use it in function notation. So a is my dependent variable, t is my independent variable. So I'll have a of t instead of y of x equals negative 500 t plus 10,000. So it says to use appropriate variables, so we should use a and t instead of x and y. Okay, one last question. Number 11, volume of gas left in a tank after t hours is given by 100 minus 20t. Okay, so we're starting out with 100, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ticks vertically. My y-intercept has to be 100, so if I go up to the 10th tick, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, call that 100, and 1, 2, 3, 4, 5 will be 50, and so on, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and subtracting 20t, so every hour we lose 20 liters, so after 5 hours, when t is equal to 5, this tank will drain down to the bottom. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ticks horizontally. If I make every 2 ticks count for 1 hour, that'll get us to a fully drained tank at this point. So after 1 hour, we drop 20 liters. So we're down to 80. After 2 hours, we drop another 2 liters, or sorry, 20 liters. So we're down to 60. And okay, 3 more, or 1 hour later, we're there. 1 hour later, we're there, and finally there. So that looks good. Draw the graph, scale. Okay, so volume, liters, time, hours. I guess we should have t. This is v. What's the slope? The slope is negative 20 liters per hour. So it represents the rate of gas consumed per hour. So gas consumed per hour. Okay, right. So what's the V-intercept and what does it represent? So the V-intercept is 100, and it represents the amount starting in the tank. Starting in the tank. Okay, so that's it for me for today. Please try these questions and do the assignment in EDSB, and I'll see you next time.